Okay, and we are live. Hi, GM, everyone. Welcome to our final session of the bootcamp on AI agents on Celo. So we've been having it's been a very tremendous 4 week period. We've learned a lot of things, so many things. And today we're having a guest speaker who's gracing our session today. I'll leave him to introduce himself, but just a quick overview. He's called Viral Sangani. He's definitely in Celo Foundation, and without further ado, I'll let him to introduce himself. Yeah, and we can talk about what we'll be going through this session. Yes, the GM guys, and thank you for joining.
Yeah, hello everyone. My name is Viral. I'm working at Celo for almost 3 years now, and I'm developer relations engineer. And currently, I'm working on a lot of AI tooling and in general, just tooling on Celo. And yeah, you can reach out to me on Twitter if you have any issues or if you want to talk to me. Snake, can you share my screen?
Okay, let me just share your screen. I've
Yeah,
added it to stage.
there we
Yes.
go. Okay, awesome. So today, I'm giving a quick workshop on understanding multi-agent AI systems because I'm aware that in the whole throughout the workshop, throughout the month, you guys have seen how to create AI agents and different AI terminologies. But this workshop will be a little bit advanced, and the idea of the workshop is to just spread awareness on what are the capabilities of AI agents and how you can just create not just create one agent but multiple agents to achieve bigger tasks. So yeah, let's deep dive into it. What is multi-agent systems? So multi-agent or MAS in short consists of multiple autonomous agents interacting within a particular environment to achieve an individual or a collective goal. So normally what we implement or what we see a tutorial on is there's one AI agent that has multiple tools access to it, and it just takes a user prompt and decide which tool is the best one to call. It calls the tool and gets the response, again put it back to a LLM model, and then it generates a user-facing or a user like a normal human message with that response. So that is a normal AI agent, but it's very restrictive. I'm hearing a echo.
It's okay. I've muted the mic. Yeah, you can continue.
Ah, okay, okay,
Sorry.
perfect. Yeah, that is what a multi-agent system is. Why do we need multi-agent systems? So there are two main reasons for it. The first one is it handles complex problems beyond a single agent capabilities. As I said, like the normal agent or a one single agent would be able to just call 5 to 10 tools and then it will return you some response. But it's very restrictive. It's not exactly autonomous agents. Like it cannot do complex tasks based like with its own capabilities. The second reason why you should learn multi-agent systems is efficiency manages dynamic, distributed, or large-scale environments. So this is more for a product, let's say for a corporate or a major enterprise level product where you have a lot of tools or a lot of product and you want an AI agent that can do everything. So this is what a multi-agent system solves. That if you want to interact with, let's say, a blockchain and then generate a report on it, or you want to do a Google search after that, all these things are different agents in themselves. And if you want one single interface that can do everything, is what multi-agent allows you to do. Let's see core components of multi-agent systems. So there are high-level four more major components. The first one is the agent itself, an autonomous entity capable of perception, reasoning, and taking some actions based on the capabilities that it has. The second is an environment. The environment is just a technical term which gives context and a processing power basically to operate on a particular task. Just a context aware, like a context given to an agent, that what it can do and what it cannot do. And the two major pieces is communications and coordination. These are the two complex things that you need to learn to create a perfect multi-agent system. The first one is communications, like methods or protocols enabling agents to exchange information. Now, since we have multiple agents, each agent should know what other agents can do so that it can share information in a secure way. And communication and coordination between multiple agents is the key to creating a scalable multi-agent systems. The coordination is the strategies for managing interactions to achieve coherent goals and actions. So let's say you give a task and all the agents should be aware that what a particular agent can do in order to achieve a perfect response or perfect output that a person is expecting. The coordination and communication for me is the most important piece in our multi-agent systems. There are a lot of ways on how you can architect it, but I've like noted down four top and most famous agents that you can look into. The first one, the most common, is reactive agent. Reactive agent is a direct response to environmental stimuli. So it's like an LLM node that you just question, it's a question and it just returns you the answer. No memory, no internal models. It's very quick and real-time actions. It's the simplest one that I gave the example about like before. That's the single agent that takes an input and gives you an output. There's nothing complex happening here. But you can basically join a lot of reactive agents to achieve a very complex task that we'll see in next few slides. That is the simple reactive agents. Next, we have deliberative agents that uses internal models for planning and decision makings. When you give a question or a prompt to an agent, uh, it needs to think itself and create a plan before actually implementing. And this is what deliberative agents allows you to do. It's capable of reasoning. It's slower, but it reduces the hallucinations that a LLM will do. Because a lot of times when you give a very big prompt, there are high chances that your agent or your model will just hallucinate and will not give you a proper response. But if you're at a planning or a decision making phase before actually executing it, now the agent will plan accordingly, like it will give it steps on what it needs to do, and after that it will execute everything. So deliberative agents is a little bit slow because it has to create a plan, but it's more accurate and it reduces hallucinations. And there's a hybrid approach where you combine both reactive and deliberative method for balanced responses and reasoning. The thing is, if you write a query, let's say hi, it does not require decision making and planning, right? It's just a normal hi. Or you can just ask, what is the time right now? It does not require planning. A reactive agent can quickly give you a response for those kind of questions. And if you ask, let's say, give me a investment strategy on Celo for this particular token. This is a very big and a complex query that needs a planning and a decision making. And this is where the deliberative agents comes in. So you can find an hybrid approach where the small queries will be managed by reactive agent and the complex can go to deliberative. There's cognitive agent that's capable of advanced learning, reasoning, and adapting to complex environments. This is like pretty advanced, and not a lot of people are doing it, but it takes more context and learns while doing a work. So it's out of the scope for this workshop, but just to spread awareness that if you're interested in this, you can just Google and learn more about it. Now, as I said, like hybrid and communications and coordination are the two key aspects. Let's deep dive into different strategies. And this is the core concept of multi-agent system. Like, how would you architect your multiple agents in a way that gives you the best outcome? The first one and the most famous that I would prefer everyone to use if you're just started building something is supervisor or centralized coordination. At a very high level, there is one LLM or one agent, and it has a lot of sub-agents connected to it, and a single entity that coordinates different agent actions. So when a user queries something, it goes to the supervisor agent, it decides which is the best agent that can do this work, and it just redirects the query to that agent. We'll see a demo and a better chart in the next slides. But yeah, a simple management, but risk bottleneck and failure points. So the only problem with this architecture, I would say, is your main supervisor node. It's a bottleneck. This When I say bottleneck, it means that it can slow down your system because one agent is responsible for distributing the work, and this agent or this particular supervisor agent will have all the load in your system. That's the only bottleneck or a failure point, because if this fails or if this breaks, nothing will work in your system. So it requires a bit of scalability and more processing power to run on a different server. There are a lot of architectures in Web 2 that you can learn on how to scale a particular uh, system. But that's the only bottleneck. But if you're just building and trying it out, don't worry. Like, unless you have, let's say, 10,000 to 50,000 users, you're fine. So this is a high level example of supervisor agent. On a very high level, let's say you have one agent which is connected to two different agents. One is a math agent and one is a search agent. So when a user sends any query to a supervisor agent, it will think that is this a math query or is this a Google search query? And based on the user's query, it will redirect the request to a different agent. And if it's, let's say, a normal query like hi, then supervisor is capable enough to just respond and not redirect the request to any agent. So this is a very high level view, but let's see how an handoff or an actual example will work. So when a message or a prompt comes into the supervisor, supervisor will hand off the task to a particular agent. It could be a math agent or it could be a search agent. When it receives the prompt, it goes to its own LLM. Each supervisor, math, and search is connected to a LLM node. So it has its own capability to decide what to do, right? So when a request comes to supervisor, if supervisor thinks that does it require any agent? If yes, then it will hand off the prompt to a particular agent. For this example, let's say search agent. So yeah, it will go to search agent. Now search agent has its own LLM. So let's say you ask what is LangChain. So the search agent will pass the query to an LLM, and LLM will decide which tool to call. So let's say you have a tool that search on Google. So now LLM will ask tool to make a Google search and ask what is LangChain. Google will respond some response. This response again goes back to LLM. LLM will convert it into a human readable form. That's just LLM, LangChain is this, this, and this. It's like 2 to 3 lines of text that LLM will curate. Now LLM will give it back to the agent, and the agent will output the main response to the supervisor again, and supervisor will send it as a response back to the user. This is a whole architecture on how a supervisor agent would work. And the more complex one is agent swarms. Agent swarms is something that I won't recommend you if you're just learning out. I would say start at supervisor agent. Agent swap is what it makes it super difficult, basically. So agent autonomously coordinate, no central control. So it can be faster than the supervisor one because supervisor takes all the knowledge and then decides what to do. So it makes it slower, but it's still manageable in terms of developing it. But when you talk about agent swarm, there's no supervisor, and each agent has to have context about all other agents. So when a request come to, let's say any of the agent, let's say this is the first agent, a request comes here, this agent knows what every other agent does, and now this agent will decide, should I do the work or should I delegate this to a particular agent? Now this, let's say this user decides that this agent decides that this is the perfect agent to do the work. It will send the request to this agent. It will do its work, and now it thinks, this work is not completed. Let's send it to this agent. Now it will send it to this agent, and it will do the work. And then, if the work is complete, it will send it to the user. So the biggest task here is the coordination. Let's say you have 5 agents, it's still manageable. But the moment you add sixth agent, you have to make sure that all other agents are aware about the sixth agent. But in case of supervisor, you can just add one more node and tell supervisor that, yeah, this agent exists and you're done. Like literally 5 lines of code. But with this, a lot of changes are required. This is faster, no doubt, but it is more expensive in terms of LLM requests, and it's basically more complicated. But let's see an example on how an agent swarm would work. I've taken an example of a flight booking and a hotel booking agent, where let's say a human says, book me a flight. The request goes to the first agent. So here, when I said like it goes to any of the agent, there's no supervisor. So it will choose randomly any one agent. So let's say choose flight agent. Book me a flight. It says that here is your flight details. It sends this back to the user. Now user says, okay, let's book it. And the request again goes to the flight agent. Flight agent say, okay, it's booked. It goes back to the human. Now the human says, book me a hotel. So now again the request goes to the flight agent, but flight agent cannot book a hotel. So it hands off the process to the hotel agent because flight agent is aware that there is another agent that can book hotels. It will just send or forward the request to a hotel agent. Hotel agent will be like, yeah, here is the hotel. It sends the whole request back to the user, and users will be like, yeah, just book it. Then the request now again goes directly to the hotel agent because the last agent that it interacted with was hotel agent, and it books the hotel and then just give a response. There's a very like small example, I would say, for multi-agent swarms, but I can see that it can be very big because in a normal application, when you start building, you'll see that 5 to 10 agents are minimum when you're building any applications. Yeah, this is a very high level example on how a handoff between multiple agent works. So let's see advantages and disadvantages of multi-agent systems. So advantages, I would say, is improves scalability to large and complex problems. So if you're solving a very simple problems like just a calculator, then yeah, this single agent is good. But if you're solving a very difficult problem, then multi-agent solves it for you, and it's pretty scalable. The single agent, let's say, agent has access to 10 tools, that's fine. But the moment you start adding more tools to an agent, let's say you have 50 agent, now your agent will start hallucinating and it will not be able to decide which is the best tool to call. And in this case, you have to scale your application. And when you scale, you have to move from a single agent to multi-agent. So that's a very big advantage, I would say, is scalability and handling a complex problem. Second, I would say is enhanced robustness and fault tolerance. Um, Fault tolerance means, let's say, if one of your agent breaks, it can loop back to the actual supervisor agent and then start the whole process again and make sure that you at least get some response. It will not break. It has its own fault tolerance mechanism that makes sure that your user does not see any kind of error. It's always useful information that your end user receives. This is how a multi-agent system helps you with fault tolerance. There's flexibility in adapting to dynamic environments. I would say, let's say, again, the same example that your supervisor agent has two agents, and you want to add a third agent, but you don't want that third agent in your same server. Let's say you want to have a new server with a new agent, which is very big. You can choose the different servers and deploy a new agent there and just tell your supervisor that, yeah, I have a new agent, but it lives on a different servers. So this is what that means, that it can handle dynamic environments. Dynamic environments means a different servers. Then we have challenges. What are the challenges? Complex communications and coordination mechanisms requirement. Again, the same thing, like communication and coordination is the most difficult piece while building. It's not that difficult, but it's the most important piece you have to figure out while creating multi-agent systems. And the potential security risk and trust issues among agents. Yeah, like when you're sharing information, you need to make sure that secure or sensitive informations are not being shared among agents. For example, in this example, when I'm booking an hotel, I don't want my flight agent to know my credit card details while booking the hotel agent, right? So the communication of information should also be in a secure and a trusted way. Then we have managing unpredictable emergent behaviors. This is also something, let's say a user asks something that agent cannot do. Then it might go into a loop, a forever loop that will just keep on checking if I have an agent or not to do this. This is something you have to manage by system prompts where you just ask that if I don't have an agent, just end the query or just end the process. There is also workaround with it, but this is one of the challenges that you can face. Let's see what are the multi-agent system use cases in specifically in Web3 or crypto or blockchain industry. The first one I would say is DeFi, like agent that handles lending, borrowing, and liquidity provisions. Because right now a lot of people use crypto, but they don't know how to use lending protocols or liquidity protocols on Uniswap. A lot of there are protocols that a normal user who is not that tech savvy does not know how to do it. Right. So, sorry. So yeah, a DeFi agent is very helpful in doing all those things for a user. Then we have a market-based agent dynamically adjusting yield farming strategies. So let's say you have invested in a particular lending protocol or a pool in Uniswap. An agent can dynamically adjust your strategies to get maximum profits. This is also one of the example. Then you have distributed consensus and governance. This is related to DAO, where an agent can participate in a consensus protocol or voting on an agent managing DAOs. Like an agent can be voting on a DAO governance proposal. Then we have on-chain analytics and monitoring. Like agents can analyze blockchain transaction and can detect if a particular agent is a fraud or if it's following a compliance or not. There are agents that will be live 24/7, which will be tracking each and every transaction on a blockchain and then make sure that everything is on track on the blockchain. This is also one of the example, which is quite difficult to do, but a lot of people I know, yeah, the people are actually doing it. There's identity management. An agent can verify and manage digital identities securely and privately for a user. So these are the some of the examples that I just put it down here. There are a lot that you can just brainstorm with an foundational model. Just go to ChatGPT and just brainstorm your ideas. This is what I normally do. If I have an idea, even if I don't have an idea, I just go to ChatGPT and start talking ideas, and you can find better ideas in this way. But yeah, it's demo time. Let's see. So I have created a project. It's an example of swarm. It's using LangChain and creating a swarm example that we just discussed or we just saw in the slides. But before going into the code, I would like to show the actual GitHub repository, which should be helpful. So the code is at celo.org slash multi-agent system. You can just go to celo.org and you can search for a repository here. Just search for multi-agent and you will find this repository. And it's open source. You can feel free to contribute. And you can see all the features here. So it's a supervisor agent. There's a web search agent. There's a blockchain agent that fetches Celo blockchain data. There's a memory management. So you can continuously talk to an agent and you just don't have to maintain the memory. It knows what you're talking about, right? Then it's built using Gemini AI, but you can tweak it around to work with OpenAI, Claude, whatever you want. But this particular example uses Gemini, and it has thread support for maintaining conversation state. And this is a very high level architecture of it. So I'll just first go through the architecture so it's easy to go through the code. So this is how the flow works. A user interacts with the main application and user gives a prompt. The prompt goes to the supervisor agent, which is using Gemini, Google Gemini model. The supervisor agent takes the input and decides if this particular prompt is a search agent request or a blockchain agent request. So if let's say take two examples. Let's say the first request was what is weather in London right now. So this is a proper search agent. So supervisor agent will decide that yeah, this is a request for search agent. So it will redirect the query to search agent. Search agent has its own set of tools. Search agent will direct either a search web or a news. And this is not a news, it's just a normal search. So this particular tool will make a call to Google or let's say DuckDuckGo or Brave or any search agent. It will find the temperature on London right now and will return it back to the search agent. And search agent will return it back to the supervisor agent, which uses Google Gemini to create it into a human readable form. So let's say in London right now it's 5 degrees Celsius. So the search agent will just return 5 degree all the way here. And the supervisor agent will take Gemini and convert it into a human readable form. The temperature in London is 5 degrees Celsius, just one liner. And this response will go back to main agent and eventually to the user. And let's say user asks, what is the latest block number on Celo? So in this case, supervisor agent will say, yeah, this is a blockchain agent query. It will redirect the question to this agent. The agent will now decide, I have three different tools, which is the best tool to give me the answers. So it says, get latest block number is the tool to do it. It will do the whole RPC call, fetch the latest block number, send this back to the supervisor agent, and the supervisor agent returns it back to the user. And it also has a conversation state where it maintains the memory while having a conversation. So let's say in your first prompt, you said, my name is XYZ. And in the next prompt, you say, what is my name? It knows the whole context of your conversation, so it can answer those things. So you don't have to give the whole prompt again and again. You can just have a continuous conversation in the same chat. So this is also something that comes inbuilt in this example project. And running it is very simple. You just go into the project, and I would recommend you to create a virtual environment in Python. If you don't, that's also fine. but you can just use pip install e and then def. This will install all the dependencies. Then there is an example env file that you can provide the environmental keys. We'll see this while coding, and then you just run it with python main.py. You can see the project structures and how it works after the workshop. Let's go into the code again. So as I said, we have a main project that you can run, and here is the README, here is the project description, and here are the dependencies that we are using. We are using LangChain, LangGraph, LangChain. We are using LangChain, Google Gen AI for interacting with Gemini. Then we have LangGraph Supervisor. This is the package that LangGraph offers. You can just search and you can find this package. This is what I'm using. You can read the whole README here. But we are using Web3 to interact with Celo. We are using Tavly. Tavly is a really good project that is free for using at a certain extent. So you can actually try it out, create an account, and it can connect your agent to web. So it can basically search internet and give you the response. And it's very simple. Just create an account, create a free account, get an API key. We are using Pydantic for typings, and there are some dependencies that we're using here. Let's see. On main, we have a helper function that receives a message and then just formats it for beautifully looking in the terminal. Like it just beautifies the text. It's nothing big happening here. I'll skip that. And detect a dictionary to LangChain. This is also one of the helper function that, yeah, it's not nothing big happening. It's just converting your message into a LangChain compatible message. So in LangChain, if you know, it only receives human message or AI message or system messages. So this particular function will convert normal string into a LangChain compatible messages. Here is our main project, which starts with some helper functions, and then it interacts with the multi-agent system. But before going, um, okay, let's go to the code and then we can see the demo. So here we takes the input from the user and then we just converts into a human readable form, and then we invoke our multi-agent system. And what we have to give them is a multi-agent, the actual agent, the human message, and a thread ID. Thread ID is something that we create for every new user. Whenever the main script starts, we create a thread ID, and this is the same thread ID that works um, for all the conversations. So let's see what is the main agent system. If you see, we have a function called create main agent inside main. We'll go into the main agent system. This is the supervisor that I was talking about that has context to for everything. So in supervisor agent, we first create a model for Google Gen AI. This is just a normal class that is coming from LangChain. It takes a model name. It takes a temperature and takes the Google API key, and it will create a LLM model that you can interact with. So we are not creating an supervisor agent yet. This is just a model. Then we create two sub agents, the blockchain agent and the search agent that we just saw in the diagram. So we just created two agents, nothing big happening here. This is where we create our supervisor. The create supervisor function is actually coming from the LangGraph supervisor. They've created a function that will create a supervisor agent. What it takes is all your sub agents. Let's say for this, I only have two agents, blockchain and search. But if you have, let's say, 10 agents or 50 agents, you can just provide the list of agents here. And now your supervisor agent will know what agents you have and what each agent can do. We have a model, we have output mode, which is just something that supervisor agent requires. You give a name to the supervisor agent and you give a prompt. In the prompt to explain everything, that what it can do, what it cannot do, and if a search query come, where to go, if a blockchain query come, where to go. This is where you give instructions to your supervisor agent. And then we are just creating a memory in memory to store all the conversations. And then we are compiling the graph because since this is built using LangGraph, you have to compile the whole supervisor agent. And this is the helper function that we used, if you remember, in the main. This is the function that we created that will actually invoke the agent. Here we are only creating the agent, right? Here we have just created the agent that returns the agent. but this is the function that actually invokes that agent and like basically have a conversation with it. So here what we're doing is intake a agent name and then just give the user prompt. That's all. Nothing big happening here. So yeah, this is the high level of how a supervisor is created. Now let's see blockchain agent. So again, we have a create blockchain agent function where we are again creating a LLM model, same as before. And here we are listing down all the tools that this agent has. We have three tools: get latest blockchain, block number, latest block info, and Celo stats. So if you see, I have a tools section where I have listed down all the tools. So we have blockchain tools. So tools are really simple. You create a normal Python function, but here you have the decorator. This is something that Python has, which you can import from LangChain, and you just add the tool, and now this particular function will convert into a LangChain tool. So all you have to do is just create a normal function, and this particular one word will convert this function into a structured LangChain tool. You don't have to worry about how would I create a tool. Just write a normal Python function. That's all. The important piece here is the doc string. So the documentation, or this is what we call doc string. Doc string. So this is what we call doc string. And this is really important because whatever we write here will be given to LLM. So all you have to do here is just write what it can do. Like it gets the latest block number on Celo and it returns the latest block number. That's all. But if you take a complex example where it inputs, like intake something, then we have to also provide arguments that it takes a block number. The block number is to get information for. It's not provided, get the latest block. So here is something that you tell LLM that what this function takes and what it returns. And yeah, that's pretty much it how you create a tool. Let's not say that. Okay, so this is how I created different functions and then I just added it into a list. This is the list, and I provide that list to create React agent. If you remember from our slide, the simplest agent we had was a React agent. So here I'm creating a very simple agent from, again, LangGraph. LangGraph has a pre-built function that can create an agent for you. So in just 5 lines, you can create a React agent. So you provide a model, you provide all the tools, you give a name and a prompt, what this agent do. Similar to how you did it for supervisor, same way you do a blockchain agent. And in search as well, I have two particular functions that runs on Tavily. We'll take a look at the tools as well. But same thing, you create a model, you create a list of tools, and then you create an agent, and then you just return it. That's all we want. Let's quickly look at the search tools. So we have two search tools versus search web. So here I'm creating a Tavily client. So it's coming from the Tavily SDK. So yeah, you give the API key, you create a client, and this particular code will search the user query and it will just return everything. So this is just for formatting. This is very basic stuff. Again, here, if you're doing something related to news, Tavily also has a topic where you can search news as well. And here again, we have formatting because Tavily returns data in a particular way, and we have to format it to make it easy for LLM to understand. Yeah, this is how we create tools and this is how we create search agent. So right now we have three agents, a supervisor agent, a search agent, and a blockchain agent. And supervisor agent is connected to our blockchain agent and a search agent. This is a very simple example on how you can create a supervisor agent and then invoke it using just dot invoke function. So you create your agent, supervisor agent, and then just dot invoke and give a message and it will handle everything for you, right? We have agents, we've gone to tools, and we have some utils like fetching the environment keys, and if anything is missing, then it'll print out an error. That's a very basic thing. And I'm using Gemini 2.5 Flash, but you can use any model. Like these tools are very basic, so yeah, you can use a small model, does not matter. I have an env example where you have to provide three things. So I would recommend to copy this file, create a .env file, and put in your Gemini key, the Tavily key. Also, Gemini key is free. You don't have to provide your credit card keys. Just go to Gemini, Google AI Studio, create a key, put it here. Tavile is again just go to Tavile dashboard, create an account, get a free key, put it here, and we are using Celo's of like free node. And yeah, just create a .ini file, put all the keys, and you should be good to go. Let's open my terminal and run the project. So we can do uv run main.py. So I'm using a tool called UV. I highly recommend everyone to use this. It's basically NPM for Node.js. If you're aware about Node.js, we have NPM or we have Yarn. So all these are for JavaScript, but for Python we have a tool called UV, and UV basically runs like NPM. So you can do UV run main.py, and it will just start main.py project. Yeah. It gives you some prompts that, yeah, it's initializing the multi-agent, it has initialized it, and it has created a thread for us. So all these prompts are coming from main.py. This is where we have added all the prompts, right? So it says, ask a question. Let's start with hey. And it's give you, hello, how can I help you today? So if you notice, it did not call any agents because it does not require any agent call. But here, if I ask what is Celo blockchain, and this is a Google search or a search query, right? It does not have to interact with Celo. So if you can see, it actually interacted with a different agents and then actually give you the response. Let's try something new. Oh, shit. Let's again start with hey. Let's make sure it's work. Let's ask what is the latest block on Celo. So now this is where it's thinking what to do and then redirecting it to the user. But here you can see it has successfully transferred or hand off to blockchain agent. So our supervisor agent decided that this particular query needs to go to blockchain agent or blockchain expert. It goes to the blockchain agent, and then blockchain agent will basically make a tool call, and the tool call will return this number. This number is returned back to the supervisor, and supervisor will just return it back to the user. So that's the latest block on Celo is this number. This is where you can track down how a particular query is going through. Like when you ask a query, it will go down all the way to a particular tool call, gets the response from the tool, and then again make a human readable message and then returns it back. So yeah, that's I think all. You can again find the GitHub repository on the Celo org. If you like it, feel free to give a star. And if you find any issues while running it, feel free to create a issue and tag me on the issue. Um, I think that's all. Thank you so much. You can reach out to me on Twitter at Viral Sangani _. And yeah, that's all.
Yeah, thanks a lot, Viral, for this really awesome tutorial. We'll be sharing all these links. My first question is, where can we get like these slides? Would you please share these slides and the resources so that we can share it with our bootcamp participants,
Yeah,
please?
yeah, sure.
Okay, so the floor is open for anyone with questions to ask. In the meantime, I have a question for you. So last week, when we were having a session on building an AI agent, we were building it from scratch using Python. And one of the main
Yeah.
questions we were asked a lot was about security. So how do you, in terms of, because you're exposing a lot of things in terms of APIs, etc. So when building this complex AI agent architectures, how do you build with security in mind to ensure you don't accidentally release, example, the API keys and any other any other sensitive information? Yeah.
So the easiest way would be creating a .ini file and putting it into gitignore. But let's say if you're working with a lot of very sensitive API keys, then you have to move towards secret managers. So there are three big companies, right? Google Cloud, AWS, and Azure, and each of them have something called secret managers. So secret managers basically secretly keeps all your API keys and in a secure way allow your application to access it. So what you do is go to, let's say, AWS, use the secret manager, put all your API keys into AWS. And now those API keys are never exposed in your code or to any of your developers. And you don't have to expose your API keys because it only needs to go into the production servers. You put your keys onto the AWS, and now whenever you deploy your application, AWS will provide your API keys to your production environment and it will just work. And locally, you can use your developer keys or dummy keys. So that is the most secure way to handle API keys.
Okay, okay. And yeah, so the floor is open. Jordan, do you have any questions?
Yeah, maybe in terms of security in the perspective of the user, apart from the developer side. Yeah.
Uh, what do you mean? Like, can you give me an example? I didn't get it.
In the first the question is security per the user, security per the user, like the users who gonna be interacting with the AI agents. Sometimes they do need to maybe like provide the private key so that they can
Okay,
be able
got
to,
it.
yeah.
Okay, I know what you're saying now. So what I would prefer to do is use Wallet Connect in this case. So I won't ask user to provide a private key. What I ask users to do is I show in my chat interface a QR code of Wallet Connect. So what I ask users to is use your phone, scan the QR code, and connect your phone's MetaMask to my application. So your private keys are never exposed. Let's say your agent wants to send 10 CUSD to somewhere, a notification will come into your phone to do the transfer. You accept the transfer and it will just work. So you never expose your keys, but this is not fully autonomous, meaning that there's still human in the loop. Like human will have to approve the transaction. So it's more secure and yeah, you're not exposing your private keys.
Okay, awesome, awesome. um i I had another question regarding the uh when you have created like multiple agents. So let's say one is interacting with on-chain functionality, the other one is interacting with like the way you had created the certain the blockchain part. um, is it recommended for the developer to store the thread IDs or the conversation IDs in a database? And
Yes.
yeah.
So if you are creating a front like a web server, and it's highly recommend that you store. So how I would do is I'm hearing an echo by the way. Sorry, there's an echo. Okay, yeah, good.
So it
So
was me
what I
saying.
would recommend is create a user ID and then store multiple thread ID for each user. So it's like ChatGPT where you log in and you have multiple chats. So each chat is a thread ID. Whenever user clicks on a particular chat, you use that thread ID for the conversations. Yeah, store the thread ID and in terms of storing the conversations, there are multiple ways you can do it. The easiest way that I showed in the demo or my example project is storing it in the memory. So the moment you close the application, your memory is gone. But there are multiple options that LangChain provide, which will store your conversations into, let's say, Redis or a database like PostgreSQL. So you don't have to manage storing all the conversations. There are inbuilt packages by LangChain that you just use and it will store it to a particular location in terms of in, in place of the thread ID. So yeah.
Okay, awesome, awesome. I don't think I have another question. Maybe from the chat. Uh, Guys,
Yeah,
feel
I
free
think
to drop any questions.
we've been answering the questions. Uh, Yeah, we've been answering the questions as you continue. So, yeah, I think we've answered most of the questions that guys had on the chat. So, in the event that we have some guys streaming in also from Twitter. So, in the event you have any questions, any comments from there, please you can caption it below our Celo Africa DAO Twitter account so that we can be able to answer them from then on. But thank you so much, Viral, for coming in in this guest session. Could you maybe kindly share your contacts if someone where someone can reach you, and then I highlight them in the banner. Yeah.
Yes, I'm just posting it. This is my Twitter handle.
Yes. Okay. Yes. All right. So, thank you so much, Viral, for coming in. Thank you for showing us about the multi-agent architectures. Like you said the project is open source, right? So we'll be sharing it
Yep.
with our participants. So in case someone
Yep.
has extra features they want to add to it, they can be able to add to it. But otherwise, yeah, thank you so much for your insightful session. And yeah, I think I can now release you. Yeah, thank you so much for being with us
Thank you so
today.
much. Okay. See you.
Yeah,
Bye.
in case of okay, bye. Okay, guys. Thank you so much for joining in. Our guest was Viral Sangani. Viral is one of the DevRel engineers at Celo Foundation, and his work is mostly to create developer tooling, any toolkits, and also tutorials, documentation. That's mostly his work in Celo Foundation. And today we have learned about how to design like a multi-agent structure using LangChain. So we'll be sharing the resources in our Telegram group. For those of the guys who are joining in from Twitter, thank you so much for joining the club. This is part of the series that we've been holding for AI Agents Bootcamp. So most of our communication has been in Telegram. So in the event you haven't joined our Telegram group, that's why we'll be mostly holding our bootcamp. So kindly drop a request at the chat, and then we can add you to our bootcamp, where we always have ongoing bootcamps. But otherwise, thank you guys so much for joining in, and for our bootcamp participants. So thank you so much. This is the last session of our bootcamp. Yay, we've been any bootcamp for web dev. The bootcamps we're holding right now is for in terms of Web3. So Anuj, maybe we do like a bootcamp on Web3 development, like a front end development in Web3. If that's a request, I think if multiple people want it, so we can have like a bootcamp specifically focused on how to build like front end interfaces and how to connect with Web3 using things like within frameworks like Web3 JS, Ethos JS, etc., and essentially how you build our Web3 front-end infrastructure and ensure it connects with the backend, which is mostly the smart contracts. Yeah, so this is like a Web3 bootcamp, but yeah, in case it has high demand, we can be able to hold such a bootcamp on the same that purely focuses on front-end. Yes, I hope that answers your question. Yeah. Meanwhile, the next step from here is I'll be sharing a GitHub repo with a template whereby you can be able to present your project proposal. So this is where we will start the projects phase actually. So we want guys, you can, based on what we've learned about AI agents, I'll also share the screen where Viral showed how what you can build, example which aspects can you touch on in terms of building multi agents. So with those resources in mind, I think you can start planning and seeing what you can actually build, which AI agent you can build, so that moving on from here we can start working on our projects, and so that we can be able to support you so that you can go to the next level. So the goal of this bootcamp was to give you a foundation in building AI agents, and also to help you hold your hand along the way as you build something into fruition along the ecosystem. So with that in mind, this Thursday we'll be having a Twitter space just to as a closing ceremony for this bootcamp, whereby we've been invited guests such as Lena from Celo Foundation and etc. So we'll be talking about what next after, what sort of opportunities are in the ecosystem and in the space, and what exactly the steps that we're going to move on forward from this. Yes, so in the meantime, I'll be sharing the GitHub repository. Having It's just a template where you can input your proposals. So just clone our GitHub repo, create a pull request with the sort of project that you want to work on, and then we can start pushing you to initiatives such as proof of ship and other initiatives. And we can also see how you can get to like you can get incentives to be working in these things. Yes. Jordan, do you have something to say?
GM guys. Sorry, I wasn't in the first bit of the session, but I know you learned a lot about LangChain. So LangChain is a really interesting tool. They have a lot of interesting tool. I personally have been looking at it, and it basically has all the tools that you would want to use when you're building multi-agent. So if you're starting, you can just start with a simple AI agent, and then once you figure out how you can be able now to integrate uh, different multi different agents within your application, then you will be in a good position. The best thing is to do like the way Viral has done it. You look at a person, whether they want to interact with different agents. If you're doing DeFi, what is the first thing the users do? They do portfolio search, like they go to CoinMarketCap, they go to CoinGecko, to look for how the market is doing. They also do the heat map thing and whatever. So you can create an agent that is a market analysis agent. Then once you create the market analysis agent, then you feed that data into the blockchain, where now you can be able to make a decision. That decision now is what the user now is, or the agents will be able to make to give more information or data for you to either borrow or lend into different lending protocols or borrowing. Yeah, so come up with a flow, how the information flows in the different users, or in the specific user you have, and then you can be able to build an agent for that. And then the other interesting thing is you can basically now be able to add voice AI, I mean voice recognition or something on your agent using voice, which is will be much better for the users to do conversation with. Yeah, so I think that's what I have. Uh, and look out for the proof of ship and the ongoing hackathon, that is the mini payment or hackathon. You can apply for it and you can build. Yeah, so GM.
Yes, so to reinforce on what Jordan is talking about, we have like there's so many ideas. Like last week, we had one of our colleagues taking us through how to build a portfolio prediction AI agent. So what you do is he trained his own model from CoinGecko, whereby if you have like a token, let's say example, I want to look at the how Celo token has been acting towards the past 2 weeks. So we fetch that data from CoinGecko, and then you sort of like pre-process it so that it's cleaner, and then you write your own model logic so that it's able to like feed on top of this data that you've fetched from some of these oracles, example CoinGecko, etc, which is providing like real-time prediction on how a token has been behaving. And then based on that, you create your own your own logic, like so that it can be able, based on this, the AI agent would try and predict for the next like tomorrow or in the next 2 or 3 days, is the token going to pump or dump. And then he also implemented the swap feature, whereby if the model predicts that your token is going to dump, it swaps the token for you and then it converts it into stablecoin. So these are some of the features, these are some of the use cases for AI agents, and this is some of the ideas we really want to see what you come up with, so that we can continue to, like, there's a mentor hackathon coming up. There's the proof of ship, which always cycles in every month, and so many other opportunities for this year. And also on our end, we have our incubator program, so these are also chances for you to like come in and join in, and then we help you go to the next level and become a startup, and also help you in application of grants such as presenting grants, etc. Again, this is some of the things we'll be talking about in our Twitter space this coming Thursday. And for those of us who are tuning in from our Celo Africa DAO Twitter page, welcome, karibuni sana. And if you're also interested in submitting a project idea which you have on what sort of AI agent you want to build, kindly shoot a DM to our Twitter page, and then I can connect with you. You can also shoot a yes, yeah, you can also shoot a DM to any of us. Like this is a Celo Africa DAO, so we have Jordan, and then let me just quickly um yeah. Yes, and that's also my Twitter handle. So you can reach out to NDM to any of us. So if you want to continue with like the projects phase that we have, and yeah, so I think with that we've come to like let me just quickly see.
Maybe Cindy,
Yes.
on plans of any plans for maybe in physical meetup uh, in the various ecosystem that is Ghana, Nigeria. I know there is something, there is a hackathon which is gonna be happening in South Africa. So if you are from South Africa, watch out for that. If you are in Uganda, around East Africa, I'm not sure what is. We're gonna share more details on such. If you're in Nigeria and Ghana, last Saturday there was an event, and I hope you guys were able to interact with guys from Ghana. Yeah. So also watch out for those events. Yeah.
Okay, and with that, thank you guys so much. Please don't forget to shoot us DMs if you have any project ideas. They don't have to be like you don't need to be like an MVP stage or anything. They're just ideas which you have around AI agents, so that we can work with you and work with you, so that you can build them into something concrete in the space. So even if you're not part of the bootcamp participant, but you're very interested in sharing and building an AI agent around Celo, and you like us to like work with you in that step and also push you to the next step forward, kindly shoot us DMs, so we can add you to these things, and then we can share like the GitHub repository where you can submit your project proposal. Yeah, with that, I think we can end the end stream. We can end the live stream. Thank you so much, guys, for pulling up, for listening, and yeah, see you guys on Thursday. We'll be meeting at Thursday at around 8 p.m. Eh, Yeah, East African time, 8 p.m. East African time.
Yes.
Yeah.
And join the live party for Celo on Twitter. Celo just turned 5 years.
I think the live party is done,
Is it
right?
still alive?
No. It ended some time back.
Oh yeah, yeah, like a few hours ago. Yeah, but you can still play the recording. Yeah. So Celo just turned 5 years. It's been 5 years of uh, pro prosperity for all and mobile first thing. Yeah, yeah.
Yeah, so
Okay.
bye guys, have a lovely night. And yeah, see you guys on Thursday. And again, I'll repeat again. If you would like to join the project, if you like to submit like a project proposal, even if you're not part of the bootcamp participants, it's open to all, so that we can be able to work with you and build with you, and you can be able to see your AI agent idea come to life. right? Yes. Okay, I'll be ending the stream. Good night, guys. Thank you so much for tuning in, even if it's late at night. And yeah, continue learning. Stay what?
Stay dangerous.
Stay hungry, right? Okay. Stay hungry, stay dangerous. Okay.
Hello.